welcome back to SnT Networks. In today's video, we'll be talking about deception in cybersecurity. So we'll understand what exactly is deception, why do we need it, what difference is it making, and what are the main points, basically revolving around the advantages of deception in cybersecurity. So traditionally, what used to happen was, right, traditionally in cybersecurity, what used to happen was we were using uh, things like perimeter firewall. So for example, if this is your overall network, we would have a perimeter firewall, and right after it we would have IPS, right, and then we would have our whole network, and all this would be integrated to a SIEM, which would collect, correlate, and collate the data for all AAA purposes, and let us know that if there is any recurring pattern which can be identified to and which can be identified and help to mitigate attacks, right? And IPS would be used to basically block malware based on signature. And on the firewall itself, either we would have an AV or any advanced threat protection or a sandboxing. Okay. Now, but in this case, if you understand, all these are waiting for the attacker to attack. None of them is actually proactive. None of them is actually like, okay, if the attacker attacks, right before it, we have this mechanism and we'll block them. It's not like that. It's like when the attacker attacks, and if we have a CVE which is not marked, we will work on that CV and then we will implement it. Correct? None of them is proactive. So now we are moving on to a different type of protection called deception. Now let's get into the term of deception and understand what exactly is deception. So it is exactly like the name suggests, you know, it's like to deceive somebody. So you can say that deception in cybersecurity, also known as a deception technology, is a proactive, like I told you, proactive security strategy that uses deceptive methods, elements methods like decoys and traps to mislead attackers, detect threats early, and gather intelligence on their tactics by mimicking legitimate assets. These deceptive elements divert attacks away from the critical systems, allowing system security teams to analyze their behavior and respond effectively. Now, what does it mean? So, it means that, like I told you in traditional ones, right, we would have a firewall, we would have IPS, and all of that. In this one, what happens is, considering this is your network and you have a device here. So what we will do is we will have a similar device right here, which would mimic this additional device. So for example, I have a server here, S1. I'll create a similar server exactly like this into S2, right? And what I will do is this will be my honeypot. Now, what is honeypot? Honeypot is basically, you can say that, a device which will help the attacker to understand that this is okay, this is to lure the attacker. Honeypot is basically like a device which mimics the original infrastructure, right, which will help you lure the attacker. So S2 will be exactly like S1, but it will be false. So by false I mean, for example, let me get into a bit of simple details. You have a server in your network S1, you have another server in your network S2, and these are the users. Okay, all the users know about S1, none of the users know about S2. Nobody is even aware of S2, right? And when an attacker comes, the first point they find is S2, okay, with almost similar security, right? With sensitive data, this is called honey tokens, okay, and honeypot is the whole server. Right. So for the attacker also to understand that this is legitimate, you would need to have some, security policies. You would need it to be connected to an ED or all the exactly the production setup, so that they get the idea that this is an original server. Okay. But now since you are trying, so you would have honey tokens, which would basically be like credentials. So if a user uses this credentials or hits this server, that means it is an attacker right there. Why? Because no user No other user in the whole company knows about S2. Correct? So this makes the job easy. So now, once attacker attacks, you don't essentially block them right away. You use TTP. Okay? Techniques, tactics, and provision to basically check what exactly is the attacker doing. So accordingly, according to the TTP, you will enforce security policies. So now you know that how the attacker attacks. Okay, now you know the TTPs. Accordingly, in your security, you will use those TTPs as a feedback mechanism. You will use that TTPs, enforce those policies. So now you have a proactive approach. Okay, this is how the whole deception technology works. Now let's get into the specific points. Why deception is needed? Limitations on traditional security, firewall, SIEMs, antivirus. So, like I told you, increased stealthiness in modern attacks, ETPs, and threat alerts, right? Because now, you know, attackers are also becoming very stealth in nature. So, keeping that in mind, we are making sure that we set up decoys, wherein honeypots or decoys, wherein if anybody uses them or touches them, it immediately triggers, and you have very less attacks, very less logs also, very less false positive, very less logs. So you now know that, if a person is using the server, they are attacker. Challenges with detection, uh, you know low and slow attacks, lateral movement. Correct. And the last one is benefit. So what is challenges? Detection, it is basically like when you're using detection, not deception, right? Lateral, the attacker will go in lateral movement, or it will be very slow attack, so it takes a lot of time for you to find out. 0 days are very less in nature. Then the benefit is turns the network into a trap. So rather than you waiting for the attacker to attack and then you block them, now your whole network is like a trap. So nobody is able to reach S1, but by the time anybody reaches S2, it is directly considered as an attacker. Logs have started logging using ML or AI. You start taking TTPs, and then you monitor the whole attacker, and then you find their location, and then you do anti-forensic and all of that, right? So you are basically using reverse psychology in a certain way. Now the attacker is being attacked in a certain way. How it works: fake data and systems are planted across the environment. Just like S2, you will have multiple servers. Any interaction with this server, right? High confidence alert. This means that if anybody uses these servers, right, it means that they are the attackers. Trap attackers logs the activity and waste their time. Correct. Key benefits are basically early detection, very low false positive. Like I told you, if anybody uses S2, right, they're likely to be an attacker. Provides rich threat intelligence and works silently with no impact on users, because everybody is using S1, nobody's using S2. So no attack, no downtime. Correct. But although anybody who comes in contact with S2, how do they know the server exists? Right? They are definitely the attacker. And if they're using any honey token or the sensitive information, right, they're again likely to be attacker. How did they find out that information? Correct. So this is a very important piece of tool that is being used worldwide right now. Deception, we have multiple vendors for it. Now basically we have Smokescreen, which is acquired by Zscaler, and the other one, prominent one we have, is Triacle. Okay, we have two prominent ones, and yeah, it is being widely used. This is often clubbed with zero trust network access. Basically for lateral movement, they are placed between two networks against lateral movement, like the decoys. And if, because you can't go laterally, but if you're going laterally and you have a decoy in between and it is triggered, that means you're likely the attack. Okay, we'll talk about this in detail. This was just an intro video for you to understand what exactly is deception, and I hope this was helpful. And if you have any further questions, please do let me know. If you wanted me to talk about any other topic or questions, please let me know in the comments, and we'll definitely do so. I hope this was helpful. Thank you.